combining equations and using the definition of relative volatility, I've calculated the relative volatility for my C of the C3 mixture is very close to 1. Okay? At a whole range of temperatures, all of these different temperatures, it stays very close to 1. So this is always going to be a very difficult separation. It's going to require a distillation. You may remember I said that normally the relative volatility is about 2.83. Why? Because normally you're operating a C3, C4 splitter at these sorts of temperatures. Obviously it depends on the operating pressure, but you're typically operating at these sorts of temperatures. So these are 2 on the column if I wanted to operate at a lower temperature.
Decrease the pressure. Decrease
the pressure, okay? And if I decrease the pressure, you can see that the relative volatility gets bigger. Might infer from this is that we should always operate our distillation columns at the lowest possible pressure. That makes the components easier to separate. Now that's true apart from the always bit. Okay, sometimes you have to change the pressure for other reasons, but directionally reducing the column probably has 8 or 10 components in the feed. If you start to consider proper multi-component analysis, then you get some very complex distillation theory. We don't want to get bogged down in the theory of distillation. We're not designing columns, we're not designing trays. Yeah? We want to design control strategies. And so what we do is we make a simplified components. Okay? The definition of the heavy key component, HK, is the heaviest component that you are likely to find in your overhead product. Okay? So in a C3, C4 splitter where you've got some C2s in the feed, what we do now is to determine what that dynamic compensation is, what values we put into that dynamic compensation. Okay? And you will remember all of these procedures, and you'll remember this drawing from feed-forward control. Okay? Remember what we want to do. This is changes in feed rate. Okay? Those changes in feed rate. If I reduce the feed rate to 80, you'll begin to see them being too fast. There'll be a little bit of symmetry. If I increase the feed rate to 120, they'll begin to look a little slow. And you remember, feed forward solves that problem. Ratio feed forward solves that problem of process gain varying with feed rate. So that's what we're going to do. We're going to do it for 2 reasons. One is a disturbance projection. Okay, if the feed rate changes, we'll change the reflux, change the ripple at the right time rather than wait for the feedback controllers to do it. And secondly, it gives us a controller tuning advantage. We don't have to retune our controllers when we change feed rate. Okay, so simple mass balance, F equals D plus B. Okay, so basically it says if I change F, I've got to change D and B in proportion. In other words, I want to keep the cut constant, I want to keep the distillate cut constant, but I want to keep the bottoms cut constant. That's the principle. Okay, now if you have a material balance scheme, that's straightforward. Why? Because you either have a flow controller on the distillate or in the less preferred version of the material balance. What do we want this value to be? 0. Okay, so if there's a disturbance to the feed rate, okay, we multiply by process gain and it comes in here. So nothing happens. It's always like, why? Because I have replaced KPD with the definition of KPD, not a numerical number or a value. This is based on definitions. This applies to any process. Okay? So the fact that it changes sign isn't a problem. My name is Myke. I'm a specialist in process control. I'm based in England. Very experienced specialist. I've done 30 years of independent consultancy, working for most of the world's oil, gas, petrochemical, oil refining companies. And then prior to that, I had 10 years with Exxon, working in their oil refining in the UK. I specialise in process control, and I lead the courses that we teach here in the practical application of process control. We very much emphasise practical application. Process control has a very theoretical background in universities with a lot of mathematics. We don't teach that. We teach very much hands-on practical experience The students learn the practical techniques and then they get opportunities to commission them on a simulated process with a maximum amount of hands-on experience. Who should come to our courses? Well, obviously process control practitioners, instrument engineers, control engineers, advanced control engineers, but also we would expect to see process engineers, mechanical engineers, plant managers, process supervisors, people like that. Our course is very intensive. They cover the whole range of technologies from very basic controllers all the way up to very complex multivariable optimization controllers. All the time they are practical. Our courses also permit our students to have unlimited consulting support afterwards because they can call us free of charge and we'll give them any help that they need free of charge. That's it. I hope to see you on our next course.
Hello, my name is Irfan. I'm Instrument and Control System Engineer from BP. I'm working in Tangguh LNG site, working in rotational basis for almost 4 years now in BP. And I'm going to have a testimony here for advanced process control from Myke. And I think this training is very good, very comprehensive. With very good material and also a very simple explanation to the participants, so the participant can understand easily about the material of the training, and it is very comprehensive for me, I think, and this is one of the best training that I have ever attended so far, and I think this is very useful for my career and working because I can apply the knowledge and also the education of the training, and I definitely like it. So looking forward to getting further training from Rhenindo, maybe for another training that is good for me. Thank you.
Hello, my name is Wakid. I'm process engineer working for BP. I'm working at Tangguh LNG site, supporting for the operations department. My testimony after attended this training, advanced process control, I think this is one of the best training that I've ever attended during my career. Why? Because it's like combining both deep theory and a very hands-on practice. So I probably will recommend to those who want to deepen your knowledge on the process control. Thank you.
Yeah, my opinion regarding this training, this training is an excellent one because it gives a detailed application, detailed simulation about what we're gonna, what's gonna happen to a particular plant, to a particular process unit if you put a certain disruption to the process. Also, it gives it's a refresher for the background of control engineering, which was like 10 years ago since the last time I touched it, and also I will recommend this training to every process control engineer, especially those working on site with day-to-day activity, facing day-to-day activity on site. Thank you.
My name is Dani. I'm process engineer working for BP Tangguh LNG. My normal activities is support operation. And then I think this training very useful for me. I get better understanding about instrument and control engineering here. I believe the material I can implement in my working activities, and I can work together better with instrument and control engineer. Yeah, I hope so. Thank you.
Hello, my name is Kristi Kosasi. I'm from BP Indonesia. I attend the training Myke Process Control Part 1 and Part 2. This training for me is very amazing because the material is very related with my background studies and related with my job as instrument and control engineer. The material is very detailed, and I can get deepened knowledge and better understanding for tuning parameter for the controller and the dynamic process control.